Hi, welcome to a new session of Circuits and Networks. In today's class, we are going to see problems which are involved with loops and shared by a common branch. For example, here you have 5 volts in series with 4 ohms, which is differentiating loop 1 and loop 2. It's a common connection, and whereas in the second case, we can see there is no element connected from loop 1 to loop 2, just it's a straight line. So, how to solve these kind of problems? So, we'll start with the basics of KCL, that is finding out the branch currents I1, I2, I3 and I4 with the known currents values, that is 10 amperes, 5 amperes, 6 and 8, 1 ampere, 7 ampere. These are the values of the known currents. So in order to solve this, first you identify the nodes. So here I have identified the nodes ABCD, and I'm going to apply KCL at each and every node. So I'll treat incoming current towards the node as negative and outgoing current as positive. With that, applying KCL at node A, I'm going to get minus 10 amperes plus 7 amperes minus I1 plus 5 amperes is equal to 0. With this, I'm going to get the value of I1 as 2 ampere. Similarly, I'm going to apply KCL at node B. Then I'm going to get the value of current I2, which is nothing but 2 amperes. And when you apply the KCL at node C, you can see here incoming current and outgoing currents. You have to match it with a particular node which is equal to 0. With this, you will get the value of I3 as 4 amperes. And finally, applying KCL at node D, you would be getting the answer as 10 amperes. Comment in the chat box whether you got the same answer or not, that is I4 is equal to 10 amperes or not. It's a simple problem. Just follow the KCL and you'll get the result of the unknown branch currents. Now we'll go with the problem which we are dealing with the loops shared by a common branch. So we need to calculate the value of V1 and I2. So V1 is over this loop and I2 is over this loop. So you can treat these two as individual loops. So applying KVL in loop 1, why I'm applying KVL at loop 1? Because a voltage source 24 volts in series with 2 volts in series with unknown voltage V1 is given. So I'm going to apply KVL in clockwise direction. Then I'm going to get minus 24, the sign notation, whatever it is coming on the path I'm taking as it is. So minus 24 plus 2 plus V1, it is equal to 0. With this, I'm going to get the value of V1 as 22 volts. Okay, V1 is 22. Then applying KVL in loop 2. So I'm applying KVL in loop 2. Fortunately, 9V1 is a loop current which is also equivalent to minus I2. So in fact, I can write I2 is equal to minus 9V1. And already we are done with the value of V1, which is nothing but 22 volts. So substituting here the value of V1, and then the value of current I2 would be equal to minus 198 amperes. I hope you understood how we got this value. Anyhow, let us go to the next problem. Here you can see node P and node Q are identified, and we need to find out the voltage measured between these two. Okay, so here you can see a drop across 3 and drop across 3 on left and right side of the loops are mentioned by plus and negative sign and minus and plus sign over this particular branch, which is beneath of P. So with this, let us apply KVL in loop 1 according to the given notation direction. I1 in anti-clockwise direction. If so, naturally the drop obtained across 3 ohms, it would be plus on the bottom and minus on the top. Okay, so I1 you can calculate the value, which is nothing but voltage by total resistance. Total resistance is 2 in series with 3, that is fine, and voltage is 2. Finally, I'm going to get the value of I1 as 2 amperes, sorry, 2 by 5 amperes, and applying KVL in loop 2 in this anti-clockwise direction. The total voltage is 4 and the resistance is 3 in series with 5, it would be 8. So the value of current I2 would be 4 by 8 amperes. In fact, it is 1 by 2 amperes. Once we are done with this, we have to calculate the voltage between P and Q. So in my convention, I'm taking P to be at low potential and Q to be at high potential. This is my assumption. You can have your own assumption. So assuming point P to be at low potential and Q to be at high potential and applying KVL along the path shown by the dotted line, you can see the dotted line direction I have shown in this way, and I am going to apply KVL. So minus, because I am assuming point P2 at low potential, that is why it is minus VP, the unknown voltage, minus, the convention is obtained according to the direction of the current and already is given. So I'm taking minus on the path as it is minus 3, that is the resistance value, and the current which is flowing in this is 2 by 5. So here already we are done with I1. So I'm substituting the value I1 as it is by assuming the direction of the current in anti-clockwise. I'm going to get this drop, that is 3 multiplied with 2 by 5. And again on the path you can see this path is going towards 4, and the notation of voltage over here is minus 4. So minus is taken over here. Then it is going to the 3 on the right side of the loop. Then you can see the resistance is 3, but the current which is flowing is 1 by 2, that is 4 by 8, which gives you the value as 1 by 2. And Q is assumed to be at high potential, that's why I have taken the value as VQ as positive, and we are equating it to the 0. With this I can say that VQP value will be 3.7 volts. The difference minus VP and VQ. On the whole, I have taken the value of the drop, that is the potential difference, as VQP, which is equal to 3.7 volts. So in fact, you can also say that what would be the value of the voltage if at all it is measured as VPQ. Naturally, it would be minus 3.7 volts. On the same analysis, let us see how to measure the value of voltage between X and Y. What is the difference between that problem and this problem? The voltage here, 6 volts, is in series with 6 ohms. Though 6 ohms is connected in series with 6 volts, this is treated as dummy. Why? Because current in open circuit will not flow. Okay, so here the drop it makes it as 0, and it's a straight line, and only you need to consider 6 volts. So let us go into the problem. You have 2 amperes and the direction of the source current on the left side of the loop, it is shown in this direction, so the current would be flowing in anti-clockwise. So applying KVL in loop 1 in this way, okay, and based upon this current which is flowing in 2, we are interested in 2 ohms. So the current which is flowing in this 2 ohms would be developing the drop across 2 in this fashion, plus and minus. In the same fashion, across 3 also it will be giving you the plus on this side and minus on this side. If at all you want to calculate the drop across 5, the plus would be on this side and minus would be on this side. Anyhow, we are interested to see the path which is between X and Y. That's why we are ignoring here 3 ohms and 5 ohms in this particular loop. We are only interested in this 2 ohms. Okay, you have 30 volts over here on the right side of the loop, and you have 5 in series with 3 in series with 2. So applying KVL in this loop 2, again in anti-clockwise, I'm going to get the value of current I2, which is equal to 3 amperes. Once this 3 amperes starts flowing into the second loop, the convention of the drops across 5 ohms and 2 ohms would be in this direction. So we are interested in 5, not in 2 and this 3, because our intention is to measure the voltage between X and Y. Okay, so we know what is the voltage drop over here, this 2 over this 5, and we have in between 2 and 5 we have 6 volts. Okay, so assuming same the notation what we have done with the previous problem, X to be at low potential, Y to be at high potential, and applying KVL along this path. So I'm going to get minus Vx, clear, minus 2, that is 2, this is the resistance, and minus because the sign convention is obtained because of the current flowing in anti-clockwise direction, and the current here it is nothing but 2 amperes. So same value we are taking over here. Then you have minus 6, so minus 6, as I told you, it's a short value and it will directly connected to this particular point. So only you have to consider here minus 6, but not the drop over here, because here in an open circuit current won't flow. Okay, and the drop will be 0. Then you have 5, so 5 you have to consider the resistance value, and the current which is flowing in this loop is 3, so the positive current, and plus Vy equal to 0. Then what is the voltage value of Vyx? Vyx is equal to minus 5 volts. Naturally, Vxy would be equivalent to 5 volts. So I hope you understood this particular problem. Now again, the positions of the branch that is connecting the loop 1 to loop 2 is changed in this fashion. So how to solve this particular problem? So you have here 30 volts and plus and minus it is shown over here. Resistance is not given right now, it is not necessary, because voltage is on the voltage positive is connected to pi over here and negative is connected to the 15 over here. So the total voltage we are considering here is 30, and the resistance sum is also, fortunately it is 5 plus 10 and 15 gives you the value as 30. So when you apply KVL in this loop in this direction, okay, I'm going to get the value as 1 ampere, and once the 1 ampere is flowing to 15, it would be positive over here, negative over here, and it is A is connected to this particular resistance on the left, so that is why we are considering this part A. Then voltage here it is 20, shown in positive on this side, negative on this side. Then current will flow in clockwise. Once the current flows in clockwise, the drop across 10 ohms, it would be in this fashion, that is upper plate positive, lower plate negative. And again the current, if at all you look into this loop 2, you have 20 volts, 4, 6 and 10, it will give you the values again 20. So fortunately we got the value of current. I2 also has 1 ampere. So assuming A at low potential, B at high potential, the path we have to follow is this path, because it is we have to measure the drop between A and B in this way. Okay, just go on with the problem. A is assumed to be at low potential, so minus VA plus 15 into 1 ampere, okay, minus 5. Okay, this one we have to ignore, as I told you like in the previous problem. It's an open circuit, so the current is 0 multiplied with the resistance, it will becomes a drop, so it becomes a straight line. So this we ignore here. And again on this path you can see after 4 you have 20, that is positive over here, okay, and you have minus, which is obtained as a drop over here. So minus 10, the current which is flowing in loop 2 is 1, okay, plus VB equal to 0. With this I'm going to get the value of VBA, which is equal to minus 15 volts. In fact VAB will be equal to positive 15 volts. So I hope you like this particular session. Please share among your friends, comment in the chat box for the future notifications.